The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Hello my dear students, how are you all? Hope you all are fine. How were your exams? I hope you all have done your exams well. Today we will be moving to yet another physics class where we see the whole world in a new perspective. Today we will discuss about a phenomena which has baffled the scientific world for a very long time. We forget its existence just because it is omnipresent. We acknowledge its existence because of its absence. What do you think it is? It is none other than light. We will begin our journey with light, examining one phenomena at a time. So our new chapter is reflection of light. So before discussing what is reflection, we can recall about light what we have studied in our lower classes. We all know light is a form of energy which is required to see the objects. Isn't it? Can we see objects in dark? No. How do we see the objects? That is, the light falling on the object gets reflected and reaches our eyes. Okay, അങ്ങനെ ആ ഒബ്ജക്റ്റിനെ തട്ടിയിട്ട് ലൈറ്റ് റിഫ്ലക്ട് ചെയ്ത് നമ്മുടെ കണ്ണിൽ എത്തുമ്പോഴാണ് നമ്മൾ ഒബ്ജക്റ്റിനെ കാണുന്നത്. We cannot see objects in dark, isn't it? Then, what are things we have studied? Light travels in straight line, isn't it? What will you call that property of light? It is known as rectilinear propagation of light. Now, the third point, light does not require a medium for its propagation. Okay, and what is the speed of light in vacuum? The speed of light in vacuum is 3 into 10 raised to 8 meter per second. Okay, 3 into 10 raised to 8 meter per second. All those things we have discussed in our lower classes. Now we will move on to our new topic, reflection of light. What is reflection? See, what happens when you throw a rubber ball onto a wall? What will happen to that ball? The ball bounces back, isn't it? The same way, when light falls on a smooth surface, what happens? The light bounces back. Okay, the same medium. This phenomena is known as reflection. So how can you define reflection? When light falls on any smooth surface, it returns back to the same surface or it returns back to the same medium. That phenomena is known as reflection. So can you give me some examples for reflecting surfaces? Smooth surfaces I have told. Isn't it? Mirror. Their reflection is taking place. Then, any other? Polished surfaces, still water, etc. are examples for reflecting surfaces. Okay, so we will study about some terms related to reflection. PQ is a plane mirror. Now, what will happen when light falls on this mirror? See here, let AB be a ray of light. AB. AB is a ray of light. Okay, so when this light falls on the surface, what will happen? It returns back, isn't it? So what do we call this ray AB? It is known as incident ray. It is known as incident ray. So what is incident ray? The ray of light that falls on the reflecting surface is known as incident ray. Okay, the ray of light that falls on the reflecting surface is known as incident ray. Okay, now what will happen? Yes, look at this CD. The CD is known as normal. Okay, CD is known as normal. So, what is normal? The line drawn perpendicular to the reflecting surface at the point of incidence is known as normal. Once again, the line drawn perpendicular to the reflecting surface. Reflecting surface na perpendicular ആയിട്ട് വരയ്ക്കുന്ന line. Okay, അത് എവിടെ വരയ്ക്കണം? It should meet at the point of incidence. വെറുതെ എവിടെയെങ്കിലും വരയ്ക്കണം അല്ല. Okay, so the line drawn perpendicular to the reflecting surface at the point of incidence is known as normal. Is it clear? Now, what will happen to this incident ray? This incident ray gets reflected back, isn't it? It gets reflected back. This is known as, EF is known as reflected ray. It's known as reflected ray. So, what is reflected ray? The ray of light that gets reflected back is known as the reflected ray. Is it clear what is incident ray, normal and reflected ray? What is incident ray? The ray of light that falls on the reflecting surface is known as incident ray, and the ray that reflects back from the reflecting surface is known as reflected ray, and the line drawn perpendicular to the reflecting surface at the point of incidence is known as normal. Okay, now see here, what do you call the angle between the incident ray and the normal? The angle between the incident ray and the normal is known as angle of incidence. Okay, once again, the angle between the incident ray and the normal is known as angle of incidence. So what will you call the angle between the reflected ray and the normal? It is known as angle of reflection. Is it clear? So we have discussed about incident ray, normal, reflected ray, angle of incidence and angle of reflection. Angle of incidence is denoted by the letter I and angle of reflection by the letter R. Okay, so now we will discuss about the laws of reflection. So for reflection to take place, the light ray, what happens? The light ray should fall on a smooth surface and get reflected back. So the first law is the angle of incidence is equal to the angle of reflection. Okay, angle of incidence should be equal to the angle of reflection. I is equal to R. Angle of incidence is equal to the angle of reflection. And the second point is the incident ray, reflected ray and the normal lies on the same plane. See here, incident ray, reflected ray and the normal, they are on the same plane itself. Same surface itself. So that is the second point. So what are the laws of reflection? First one, the angle of incidence is equal to the angle of reflection. Second one, incident ray, normal and the reflected ray lies on the same plane. Is it clear? So now we will discuss about another two types of reflection. Now we will discuss about regular reflection and irregular reflection. Okay, look at this first figure. See here, the beam of light is falling on the reflecting surface, and see what happens to these rays after reflection. After reflection, you can see the light rays move parallel. Isn't it? These are the reflected rays. Look at these light rays. These light rays are moving parallel. Such a reflection is known as regular reflection. Okay, that is, if the light rays after reflection moves parallel, they are known as regular reflection, or it is known as regular reflection. This plane mirror or spherical mirrors all shows regular reflection. Is it clear? Now look at this figure. Look at the surface. Is it a plane surface? No. It is an uneven surface. Isn't it? Or it is a rough surface. So what happens when the beam of light falls on this rough surface? The light rays, they are not moving parallel. Okay, that is, these light rays undergo irregular reflection, or we can say it undergoes scattered reflection. പല ഭാഗത്തേക്കായിട്ട് scatter ചെയ്തിട്ട് പോവാണ് like this. Is it clear? Such a reflection is known as irregular reflection. Then what happens? The light rays, after reflection, they get scattered. Such a reflection is known as irregular reflection. In atmosphere, this irregular reflection is taking place, or scattering is taking place. We know the light from the sun is reaching to the earth. Isn't it? While it is coming, it gets scattered by the dust particles. That process is known as scattering, that we will be studying in the coming chapters. Understood? So I hope you understood what is regular reflection and irregular reflection. We will discuss about the image formation by a plane mirror. Okay, see here PQ represents the plane mirror, O is the object. Okay, OA and OC are the two incident rays that falls on the mirror. Okay, so see here OA. After reflection, what happens? OA gets reflected back. AB is the reflected ray. In the same way, OC, the reflected ray is C. X and Y are the two normals. And see here, after reflection, whether these reflected rays are meeting at a particular point? No. Okay, these reflected rays, they are not meeting at a particular point. They move parallel. And what we have done is, these two reflected rays, they are extended back. Okay, back load extend ചെയ്യുന്ന സമയത്ത് അതൊരു particular point meet ചെയ്യുന്നത്. That point is marked by the letter I. I represents the image. Okay, അതായത് ഈ രണ്ട് റിഫ്ലക്റ്റഡ് റേസ് നമ്മൾ എക്സ്റ്റെൻഡ് ചെയ്യുമ്പോൾ, അതായത് മിററിന്റെ ബാക്കിലോട്ട് അല്ല മിററിന്റെ ബാക്കിൽ അതിന്റെ ബാക്കിലോട്ട് എക്സ്റ്റെൻഡ് ചെയ്യുമ്പോൾ they meet at a particular point where the image is formed. Is it clear? The point where the two reflected rays meet, that particular point is known as the point where the image is formed. So here the image is formed at the back side of the mirror. മനസ്സിലാവുന്നുണ്ടോ? അതായത് രണ്ട് റേസ് ഈ മിററിലെ ഇൻസിഡന്റ് ആവുന്നുണ്ട്. ഈ ഇൻസിഡന്റ് ആയിട്ടുള്ള റേസ് എന്ത് സംഭവിക്കുന്നുണ്ട്? ആഫ്റ്റർ റിഫ്ലക്ഷൻ they reflected back. These reflected rays, they are not meeting at a particular point because the reflected rays move parallel. Okay, so നമ്മൾ എന്ത് ചെയ്തു? ഈ reflected rays നെ നമ്മൾ ബാക്കിലോട്ട് എക്സ്റ്റെൻഡ് ചെയ്യുന്ന സമയത്ത് they meet at a particular point where the image is formed. So can you tell me the properties of the image formed there? അവിടെ നമ്മൾ ആ ഒരു സ്ക്രീനോ എന്തെങ്കിലും വെച്ച് കഴിഞ്ഞു കഴിഞ്ഞാൽ നമുക്ക് നമുക്ക് ആ ഇമേജ് കാണാൻ പറ്റും. നമ്മുടെ ഇമേജ് മിററിന്റെ ബാക്ക് സൈഡിലാണ് ഇമേജ് ഫോം ചെയ്യണമെന്ന് പറഞ്ഞു അല്ലേ? Can we see the image there? If you keep a screen? No. Okay, such an image is known as virtual image. Okay, virtual image. So, what is virtual image? See here the image is not formed by the meeting of the reflected rays. Okay, here the image is not formed by the meeting of the reflected rays. Such an image is known as virtual image. Or in other words, we can say the image which cannot be caught on a screen is known as a virtual image. അതായത് ഒരു സ്ക്രീൻ വെച്ച് കഴിഞ്ഞാൽ അതിൽ കാണാൻ പറ്റാത്ത ഇമേജിനെയാണ് നമ്മൾ എന്ത് പറയാ? വെർച്വൽ ഇമേജ് എന്ന് പറയാം. So what will be real image? The real image can be caught on a screen. ഒരു സ്ക്രീൻ വെച്ച് കഴിഞ്ഞാൽ അവിടെ ഇമേജ് കാണുന്നുണ്ടെങ്കിൽ that is a real image. There the image is formed by the meeting of the reflected rays. Reflected rays meet ചെയ്യുമ്പോൾ കിട്ടുന്ന ഇമേജ് ആണ് real image. See, in cinema theaters and all we can see, like the light from the projector, when it is focused on the screen, what happens? We can see the image on the screen. Such an image is known as real image. Understood? So here, which type of image is formed? Here the image formed is virtual. And see what happens when you move towards the mirror? The image form will be also closer. അതായത് നമ്മൾ മിററിന്റെ അടുത്തോട്ട് പോകും തോറും ഇമേജും മിററും തമ്മിലുള്ള ദൂരവും കുറഞ്ഞു. So first point is the distance of the object to the mirror and the image to the mirror will be same. ഒബ്ജക്റ്റും മിററും തമ്മിലുള്ള ദൂരവും ഇമേജും മിററും തമ്മിലുള്ള ദൂരവും it will be same. Okay, second point is the image form is virtual. Okay, it is a virtual image. What about the size of the image? നമ്മൾ കണ്ണാടിയിൽ നോക്കുന്ന സമയത്ത് നമ്മൾ അതേ സൈസ് ആണല്ലേ? Same way, the image is also the same size. So the 3 points we have to study. The image is virtual, is the same size, the distance to the object to the mirror and the image to the mirror will be always equal. Is it clear? Now, let me ask you one thing. What happens when you increase the number of mirrors? Whether the number of images will be more? You might have noticed the trial rooms in shops. There we can see so many images, isn't it? What is the reason for that? Or how you can find out the number of images? All those things we will be discussing now. If more than one mirror is used, what happens? Number of image also increases. That is, more than one image will be formed. Such a reflection is known as multiple reflection. That is what we are seeing in the trial rooms. So how we can find out the number of images? Okay, n is equal to 360 by theta minus 1. Where theta represents the angle between the mirrors. Okay, let us see one example. Okay, suppose if theta is equal to 90 degree, that is the two mirrors, they are kept at an angle of 90 degree. So how many images will be formed? Just see here, n is equal to 360 by 90 minus 1. Okay, what is the n is equal to 360 by 90. 0 and 0 get cancelled. What is 36 by 9? 9 4s are 36, isn't it? So 4 minus 1 is equal to 3. Okay, so the number of images formed is 3. So we can tell if the two mirrors are kept at an angle of 90 degree, the image formed will be 3. Now, what will happen if theta is equal to 180 degree? The two mirrors are kept at an angle of 180 degree. How we will keep? How? How we will find out the number of images? N is equal to 360 by 180 minus 1. Right, ശ്രദ്ധിക്കണം. Only after the division you have to do the subtraction. Okay. Here we can cancel 2. 2 minus 1, which is equal to 1 each. That is, when the two mirrors are kept at an angle of 180 degree, you will be getting and number of images formed as 1. How many images will be formed when the mirrors are kept at an angle of 45 degree? Here theta is equal to 45 degree. So we can write n is equal to 360 by 45 minus 1. Okay, what is 360 divided by 45? 8. So 8 minus 1 is equal to 7 images. Okay, so when the mirrors are kept at an angle of 45 degree, the number of images formed is 7. Okay, so you have to find out the number of images using the formula n is equal to 360 by theta minus 1, where theta is the angle between the mirrors. So, what all things we have discussed today? We have discussed on reflection of light, incident ray, reflected ray, normal, angle of incidence and angle of reflection, and we have also discussed on the laws of reflection, then the image formed in a plane mirror and what are the peculiarities of that image. And finally, we discussed on how to find out the number of images. It is found out using the formula n is equal to 360 by theta minus 1. So I hope you all have understood the topic which I have discussed today. Go through the class. If you find any difficulty, you can contact me. That's all for today. See you in the next class with a new topic.